Hello and welcome to the fourth plenary of the GSA 4G-5G Fixed Wireless Access Forum. Over the next 90 minutes, our panel of experts from across the ecosystem will share their perspectives and insights on the 4G and 5G fixed wireless access opportunity and the best practices in deploying these services. First, a little bit of housekeeping. All the presentations shared today will be available for download immediately after this event from the GSA website, gsacom.com. You can also download them now from within the webinar room by moving your mouse over the slides and clicking on the little download icon at the top right of the screen. An on-demand recording of the entire discussion will be shared with you via email immediately after the event. Following the presentations, there will be a Q&A session with our speakers. You can submit questions using the questions function on the sidebar. Please do post your questions as we go through, and then the moderators will be able to draw on them during the respective Q&As. But first, to get things started, I'll hand over to Joe Barrett, President of GSA, to formally open the event.
Thank you, Richard. Welcome, everybody. So I will just start quickly by mentioning a little bit about GSA. For those that maybe don't know too much about us. The association is not for profit and has been representing the global mobile ecosystem since 1998. Next year will be our 25th anniversary. We have 9 major industry executive companies who lead the association. And we do extensive research and maintain databases on what is actually happening out there in the industry today on 4G,
So, Joe, I think we've lost your audio. Yeah, we've lost your audio. Never mind. I tell you what, we'll leave this slide up there. Joe, give you a chance to work it out before you come back on, and we'll just move straight on to Julian. So Julian will just, I guess, cover any bits on remaining on this slide and talk more specifically about the forum. Julian.
Okay, yeah. So sorry for the technical issue. Let's move to the Fixed Wireless Access Forum part. So a warm welcome from my side. This is already the 4th edition, as Richard mentioned. I am Julien Grivola, and I'm currently the chair of the GSA 4G-5G Fixed Wireless Access Forum. I am also the director for Europe at the Huawei Wireless Industry Development Department. And we have already discussed quite a few times, for those who attended the previous editions of this event, about the role fixed wireless access should play to help bridge the digital divide. I mean, this is really a technology that can be a life changer, as we said before, bringing a reliable and strong and powerful connectivity method to those who currently are struggling to get connected or are experiencing very poor performance broadband technologies. And today, really, if we compare to 2 years ago, we see a huge momentum behind fixed wireless access, and this is happening on all continents. I mean, this is in developing economies, in developed economies. Recently, we have seen what was announced in the US. Our vice chair, John Laszlo, tweeted, for example, that 95% of the net adds in the broadband market in the US, if you consider the top 6 service providers, were coming from fixed wireless access in Q3 2022. So there is a huge momentum in the US, but there are also lots of initiatives in other countries, in emerging economies. Today, our event is more focusing on the Asia market. We know recently Jio announced a very significant objective to cover 100 million homes with 5G fixed wireless access. And as we will hear later today from the guys in Australia, from NBN, there are also lots of initiatives to bridge the digital divide, combining fiber and fixed wireless access. So this is extremely important, because we should not forget, despite the momentum, that there is a huge amount of work still to be done to connect the unconnected. Based on the ITU 2021 report, there are still 3.7 billion people not connected. So the progress on fixed wireless access is really encouraging, but we certainly need to do more. And we also have the opportunity to leverage lots of investment plans being announced at the moment following the COVID-19 crisis. So there are opportunities like we can see on this slide in Europe to leverage those funds to really boost connectivity deployment. This is why we organized this forum 2 years ago already. So we are a few weeks away from celebrating our second year anniversary. So that's good news. And in fact, so lots of companies involved in the fixed wireless access ecosystem decided to join their efforts together to push and promote fixed wireless access globally, explain what it is about, what are the benefits, also bring, I would say, some meat around the bone, because there was at the time not so much information about how many deployments were available around the world, how many CPEs, or what kind of modules, chipsets were available to support the fixed wireless access development globally. So we have been agreeing on those objectives, and we put our hands together. And this is really open to all companies involved in the fixed wireless access ecosystem, 3GPP-based ecosystem. Right now, we are 49 members. So it has enjoyed a very rapid development. We are now proud to have most of the infrastructure vendors and CPE vendors in the market. There are still some companies that we have not been able to attract, but we are working on it, and we are sure this is going to happen soon. We are eager to break the 50 member milestone before the end of the year. And as you can see on top right of the screen, really the focus was on the ecosystem side of things. And you can see we are still having lots of CPE vendors. This is the lion's share of our members. But also we have lots of module vendors as well participating. We have done quite a lot of things since our creation, always having in mind this objective to educate the market about the ecosystem. So we have published several times our kind of catalog where you can find, products from module vendors, chipset vendors, CPE vendors. This is the catalog of what we call the device ecosystem directory. We are now we have published our 7th edition in October. We also have conducted our annual study looking at the device ecosystem, setting up the main trends and so on. We are surveying our members. Last year, 26 CPE vendors participated, and you will hear more details about the results of this study thanks to Simon in the session we will have next to my introduction. We also organized several public events. The previous one was held in May. The focus was more on Middle East and Africa and Europe. This time, as I said before, it is about Asia. We also represent the voice of the 4G, 5G fixed wireless access ecosystem. So we are also contributing to some public consultations, like the one in Europe about the public stated for broadband guidelines revision. So the Fixed Wireless Access Forum contributed to this one. And today, we're also proud to announce the future availability of our 4G, 5G fixed wireless access device database. So there will be the opportunity to access details about modules, products, CPE products, MiFi products directly on the GSA Fixed Wireless Access Forum website. You will have a preview given by Joe a little bit later. So this is a really important milestone for us. And all the content is available for free when you go and visit our website. So going back to today's agenda, as I said, we will have Simon Bryant first introducing the latest market updates figures around the world. Then this will be followed by a long session with NBN, who will explain how they did deploy fixed wireless access in Australia to bridge the digital divide. And then we will move into the fixed wireless access ecosystem session where we will have representatives from FIBOCOM and Todd Skangway participating. And we will also have the demonstration from Joe. And then we will have closing remarks from the Vice Chair, John Yasler. I would like, again, to thank our sponsors, FIBOCOM and Todd Skangway, a lot, because without them, we cannot do this events. So thanks again. Thanks for your contribution. And now we will have quick videos from both of them. And we will start after that with Simon Bryant for the fixed wireless access market update. Richard, can you play the video?
The future of connectivity infrastructure is here. Today's 5G connections offer blazing fast, fiber-like speeds, and fixed wireless access can bring the power of 5G to your home, your family, your office, your branch, and your customers. Fixed wireless access, or FWA, doesn't need fiber infrastructure to get you online. Just set up an access point and you're connected. Now all you need is an easy-to-deploy, efficient, and powerful FWA solution. FIBOCOM is a key player in the field of 5G FWA, offering industry-leading 5G module solutions as well as customized supports. Our modules are based on multiple chipset platforms, making them deployable for any situation and on any device. Whether you need energy efficiency, breakneck speeds, or specific global frequency compliance, we have the answer. Our customized 5G modules keep you more than just connected. With Open CPU, we focus on optimizing performance-to-cost ratios and lowering power consumption. Our AP Plus modem solutions offer high throughput, low latency, and top-notch security. With powerful hardware comes our proprietary software, which gives you real-time speed and device information. These can be customized to meet whatever requirements your business or environment needs. FIBOCOM can deliver on the promise of high-speed, low-latency connectivity for FWA. Choose FIBOCOM. We look to offer the best 5G experience to your FWA solution.
Thank you very much. Hopefully you can hear me okay. It's my pleasure to present at this Fixed Wireless Access Plenary today. My name is Simon Bryant. I manage the research efforts here at GSA Research, which includes a team of 6 researchers and analysts who work for me and on behalf of the GSA membership. As well as supporting GSA members with various bits of information, we produce slides, we provide bits of bespoke information for members. The core of what my team produce is the Gambod database, which Joe was presenting just before he got cut off, which provides very detailed data updated on a monthly basis for spectrum, devices, chipsets, public networks, private networks, and operators. And across all of that, fixed wireless access is segmented. Drawing from the Gambod database, we also are producing approximately 80 reports per year across many different topics, private mobile networks, IoT, 5G standalone, and many other topics, and of course, fixed wireless access as well. So in this presentation, I'm going to be sharing some data predominantly from two different sources. The market status report, which is updated twice a year and is due at the end of this week to members. And that is representing the data that is in Gambod today that you can see in there. From the devices database, where we're tracking CPE devices, and the operator database as well. The other source that we're going to use, and Julian highlighted this a moment ago, is the Fixed Wireless Access Industry Survey that was last published in July of this year, based on a survey that was conducted over the 2 months preceding July. And 26 companies participated in this report, and those vendors are mentioned in the report. So let me press on and share some data from that research. First, let's take a look at the market for CPE products based on the survey that we conducted earlier this year. Device shipments here include both indoor and outdoor CPE and also battery operated hotspots. Results are the combined actual shipments of the 26 respondents who participated in this survey, which covers many major manufacturers of fixed wireless access CPE equipment. What that research showed us is that 22.7 million shipments were recorded for 2021. This was actually lower than 2020, which 2020 had experienced a surge in demand for battery operated hotspots as people required internet connectivity at home due to the impact of the pandemic. 2021 saw a correction from that period, particularly with regard to battery operated hotspots, in addition to lagging demand from the pandemic, such as product shortages and also high prices caused by inflationary impacts, which I'll touch on in a moment, all impacting the supply of devices rather than the demand for CPE devices. Although 2021 fell roughly 25% based on the sample, the data actually suggested that more than half of the sample saw growth in 2021, and it was some of the larger companies which saw declines and skewed the overall picture. 2022, on the other hand, so far, based on the research we conducted earlier this year, is expected to accelerate and grow beyond 2021, as component shortages are beginning to ease and demand expectations were healthy at the time of the survey. When asked halfway through the year, respondents were expected growth would exceed 30% for both 4G and 5G fixed wireless access CPE devices. Indoor CPE, which is the largest category, accounting for 63% of volumes, was expected to grow the most. Battery operated hotspots, although expected to grow just under 23%, were not expected to return to the levels we saw in 2020. Also from the survey, here we're looking at two factors which could account for shipment performance. On the left is the results of a question we asked around the impact of component shortages on demand of devices, while on the right, a chart looking at the impact of inflation on prices of devices. Here you can quite clearly see that the impact component shortages had in 2021, with 15 of the 22 respondents indicating that the issue was significant and affected more than 10% of volumes. From 2022, while some shortages have remained, the majority have been reporting just minor shortages. By 2023, 18 out of the 22 respondents expect no or minor component shortages in 2023. In addition to component shortages, inflation had a significant impact on prices, and a similar pattern of the issue shifting from a major one to a minor one between 2021 to 2023. However, respondents were less optimistic with inflation that it would disappear entirely, with most respondents expecting some impact to remain in 2023 as well. This survey was completed in June, and the World Economic Outlook looks fairly negative now compared to then. And so it will be interesting to see what the next survey tells us about respondents' outlook when we come to ask them next time. Now shifting my attention to, or our attention to, what we see in the Gambod database. And it tells a similar story in terms of the trend looking forward. Here we're looking at the number of CPE devices that are announced or have been announced in the purple bar against fixed wireless access services launched by operators in the other bar. While we can see that supply was constrained, this did not stop operators announcing and developing new hardware. And 2021 still saw a significant number of CPE devices being announced, growing 52% from 629 devices to 952 devices in 2021. The momentum has slowed a little going into 2022, but we have passed the 1,000 mark, reaching 1,013 CPE devices announced, with more announcements expected for the remainder of this year. The number of fixed wireless access services in the meantime by operators also continued to increase, albeit a little bit slower, at 10% from 467 services to 512 between 2020 and 2021. And then we see 529 by October. Returning back to the fixed wireless access survey earlier this year, we asked respondents to rank which trends were most important to the CPE industry, comparing the change between the survey last year and this year. Interestingly, the biggest changes were that government broadband plans and 5G launches were important in 2021, but are not expected to be a huge driver for fixed wireless access in 2022. Or less of a driver in 2022. Instead, connecting the unconnected is the most important trend, in addition to working or schooling from home and also replacing DSL. If we look at the picture from a geographic perspective, based on data within Gambod, fixed wireless access services are already pervasive. As of the latest numbers in October, we now have 629 LTE or 5G fixed wireless access services being invested in worldwide, and that's across 186 countries. Most of these, or 84%, have already launched, with 529 fixed wireless access services being offered across 171 countries. At this level, you might assume that the picture looks fairly mature, with penetration across most major countries in all regions. A notable omission here is India, that you can see isn't highlighted in the picture. Although with India's latest 5G auction, operators have announced that a 5G fixed wireless access service will soon be launched. So we can expect that to turn purple in the next update. Despite the maturity and slowing of release of services, there is still a huge amount of potential. Full operator coverage, service roll-up, and consumer adoption within those highlighted countries is another story, another layer of development. 5G is also another factor which is accelerating the growth of fixed wireless access, and we can see is already increasing potential in Europe and Asia Pacific. The US is just one good example of this potential momentum in fixed wireless access, where T-Mobile expects to reach 7 million to 8 million fixed wireless access customers by 2025. The chart at the bottom right shows Europe and Africa, Middle East and Africa, have the highest number of fixed wireless access services launched on account of fragmented geography and operator landscape. Here is one important factor driving fixed wireless access adoption, and that is the speeds being offered by services. In the latest report that we'll be sending out later this week, we capture advertised tariff structures and downlink speeds. And the majority of LTE services on the chart on the left offer speeds of less than 500 megabits per second, with more than half offering less than 100 megabits per second. With 5G, as you'd expect, advertised speeds are much, much faster. And the majority of speeds are over 500 megabits per second. And we even see a number of services offering over 1 gigabits per second and 2 gigabits per second, while we are even seeing speeds advertised up to 5 gigabits per second. Speed is one factor helping 5G adoption, which has been accelerating based on our data in Gambod, although still has a long way to go compared to LTE services, which are now starting to flatten off. By end of October 2022, 509 operators in 155 countries were investing in 5G, with 228 having launched one or more 5G services. The majority of fixed wireless access services are 4G, with 5G fixed wireless access services making up just 19% of launch services today. A large amount are still investing in 5G fixed wireless access services, just 99 have launched. We expect existing LTE fixed wireless access connections are expected to be upgraded to 5G connections. And it is reasonable to assume some incremental 5G fixed wireless access, thanks to the additional bandwidth and level of service being offered by next generation connectivity and pushed by many services. Returning to some of the results from the survey, this shows that 5G fixed wireless access shipments from the survey, that just 16% of 2021 shipments were 5G capable based on the sample, up from 4.5% in 2020. This number is expected to rise to just under or just over 1/4 in 2022 at 25.8%. Demand for 5G shipments, although small, is continuing to grow among CPE manufacturers. Despite the total sales decline of 25% in 2021, 5G shipments continue to grow 162% year on year over the same period. In unit terms, this grew from 3.6 million to an expected 7.6 million this year, based on respondents' combined sales. And coming hand in hand with the growth, coming hand in hand with the growth in sales is the launch of new 5G devices and new vendors offering those devices, which we see in our Gambod database. We see the number of 5G fixed wireless access devices at 229 at the end of September, at 25% from 182 devices in end of September 2021. The majority is indoor devices, 143, and where we see the most growth. The number of vendors offering fixed wireless access devices grew by 5 since this time last year to 75 vendors. And finally, fixed wireless access, by way of a summary, fixed wireless access is a great example of technology proving itself as a crucial connectivity option for consumers and business customers, particularly many living in hard-to-reach locations. Impressively, we are seeing advertised speeds now of 5 gigabits per second. And that's the end of my presentation. Thank you very much. Please don't hesitate to send any questions my way for the GSA research team. Thank you.
Thank you, Simon. My name is John Yasle. I'm the vice chair of the Fixed Wireless Access Forum. I'm also head of Fixed Wireless Access at Ericsson. So as Julian mentioned in the beginning, promoting the fixed wireless use case and sharing best practices is a key part of our forum objective. Then we also mentioned and discussed about the importance of closing the digital divide. And I think with that context, today we're thrilled to have NBN Australia with us, which has been a global pioneer in fixed wireless access selling speed-based fixed wireless over LTE for over a decade. And now NBN is embarking on a new journey for 5G fixed wireless access. So today we're thrilled to have Sam Stevens, General Manager of Wireless Technologies, and also Mark Barnett, General Manager of Fixed Wireless Engineering with us to share their insights. They're gonna have a presentation, and then at the end, we're gonna have a Q&A. So please post your questions, and then after this session, we're gonna have a discussion. With that, I pass the word to Sam and Mark. Thanks.
Thanks, Sean. I'm going to quickly take us through a little bit of history about NBN, just to level set, because it's a comparatively unusual network. It was set up by the Australian government back in 2009 to basically connect the continent, or at least the whole country of Australia, which, as you can see, is a pretty big place, and was somewhat prescient in that it was largely completed just before COVID. So we had close to 12 million premises, or all 12 million premises in Australia ready to connect. And as of right now, we've got about 8.5 million homes and businesses currently connected to NBN as a single wholesale network provider. So you can buy your internet service from many different people in Australia. There's close to about 100 RSPs, give or take, retail service providers that we call them here, but they all share access to our wholesale network, and it underpins Australians' access to the internet and the way we work, learn, access healthcare and all that. So we call it the digital backbone of Australia. So it's really relatively unique, I think, to have such a large scale singular network to connect to. Really quickly, COVID-19 and general data usage growth has been significant. As I mentioned, we're currently carrying a big chunk of the nation's data. Over 86% of all internet traffic is on NBN, the rest being on the mobile networks of the various telco carriers. Traffic grows and sort of continues to grow year on year. Probably, hopefully not a surprise to many on this call. And we anticipate that we'll see, peak NBN total network traffic, or you could consider that Australian network traffic, peaking at presently about 20 terabits a second is our current peak. End of the decade, we're probably seeing at least double that, close to triple that at close to 55 terabits a second. And then at the middle of the year, over 75%, 76% of homes were on our 50 megabits wholesale speed plan, which is what people buy, not necessarily the network capability, which is often quite a lot higher than that. And close to 20% were north of 100 megabits a second. So that's, I guess, the shape of broadband in Australia. We have big investment plans. The top three bubbles here relate to our fixed line network, which is around about 93% of all of the premises in Australia are served by some kind of fixed line technology. And we're investing heavily to move our FTTN and FTTC onto FTTP and enable sort of maximum wholesale speeds available progressively from the 5.1 million premises today up to north of 10 million premises by about 2025. And then the thing we're going to talk about is the investment on the fixed wireless network. So we're going to take our current network. I'll let Mark talk a little bit more about that in a minute, but we'll enable 2 new high-speed tiers. We're also going to expand the range of the existing network. So we're not necessarily going to build new towers, but we'll use some features and some capability in the network to expand the range and enable us to rebalance some of the satellite footprint onto fixed wireless, about 120,000, which in turn helps us to deload our satellites, of which we have a pair of geostationary satellites, which we use to provide access to the very last bits of the country, and help us improve the product offering there by virtue of having a little bit more capacity, or quite a lot more capacity. In terms of the way the network is split up, as I said, it's a wholesale-only network. So there was a bit of discussion that was moderately politicized at the beginning of its life, but it's settled down to being a pretty bipartisan and sort of happy place to be. NBN's a relatively positively received thing. But the country is carved up into these 121 islands or points of interconnect. They're not uniformly distributed like that. Obviously, it's more uniform population inside each of those squares, so they're heavily centered around the population zones. Inside a POI, we can have multiple technologies or a point of interconnect. We use FTTX, FTTN, FTTB, HFC or DOCSIS cable, and also the satellite that I mentioned. The only exception to that 121 POIs concept is the satellite network, which connects to a singular point of interconnect, just because the number of premises in any given location would be, any given point of interconnect would be pretty small. So for efficiency reasons, that one gets aggregated up and we translate that. And retail service providers can connect to one point of interconnect or all of them, depending on how they see they want to play in the market. And obviously the big carriers connect to the whole of Australia, and some people are much more targeted and localized. As I was talking, hopefully you're getting a sense of this idea of the different technologies. We've got, if we sort of in the metro areas, it's pretty much fixed line everywhere. If we go out a little bit more rural, we'll sometimes see a town center, or the denser portion of a town will be on a fixed line technology, and then we'll have fixed wireless serving the less dense homes, and as the property sizes get bigger and slightly more sparsely populated areas, we'll use fixed wireless for a couple of towers, and then anybody who lives or has businesses beyond the reach of the fixed wireless network, we service with our satellite network. So 100% coverage. If you live in Australia, you can connect to the NBN. We'll provide connection by whatever technology is the most appropriate given where you live and where you want to connect. And as the slide says, the star of the show today is the fixed wireless network. So I'll hand over to Mark here, and you can tell us a little bit about the story of the fixed wireless.
Yeah, thanks, Sam. So I'll talk a little bit about the way that we've brought this network to life, how it's evolved over time. It has been quite a journey. We've been running the fixed wireless network of NBN now for over 10 years, and it's evolved quite a way since the original deployment. Originally, we started with just a bit of spectrum in band 40, 2.3 gigahertz. And the network looked quite like a mobile network, like a typical mobile network. If you saw one of our sites back at the start, it was a 3-sector configuration with probably one cell per sector, and obviously not full overlapping mobile indoor coverage, but it was providing sufficient coverage over a desired coverage area, which wasn't fixed line connected, to roof-mounted devices, which you can see there. The one in the middle of the page was our old variant of what we call our WNTD. It's the wireless network terminal device. The original deployment was like I think it was a category 4 device, very basic. We're talking 10 years ago now. It was pretty successful though. As we deployed, we had a very good take-up rate. In some areas, it exceeded 60% of all the premises within the actual coverage area. Probably not surprising, since one of the original reasons why NBN needed to be built by the government as a wholesale network was to compensate for a failure in the market. One of the things that wasn't happening was reliable broadband available in the regional and remote areas. And that's where fixed wireless was being deployed. So it's pretty popular. And what happened was that the original plan turned out to be pretty underdimensioned pretty quickly. It was very popular. The original product offering was a 12 megabit downlink, 1 megabit uplink product. And the expectation was that it should provide a committed information rate or a sort of busy hour performance of about 512 kilobits per second for each customer. It didn't last that long. It met demand for a while, but what we found was pretty quickly that consumption started to go up. I mean, those rates were created and set as our targets before Netflix existed and before streaming video on demand was a thing. But the world changed pretty rapidly, so we've had to evolve the network and greatly increase the spectrum and the capacity. So one of the things we did relatively early was obtain some band 42 3.4 gig spectrum. We deployed into that. While we were deploying the network, some of the sites that we've deployed actually have only band 42 spectrum. We've got a little bit of a, you could call it a patchwork quilt of spectrum across the country, but we make it work. There's today, as Sam said, I think the consumption per user per month is now above 300 gigabytes. So there's a lot of capacity happening. And what we have had to do is to find ways to meet that capacity demand. So if you went out to one of our sites today, you would see a lot more than 3 sectors on a site. And in some cases, there could be up to actually 24 sectors on a site. We've done some pretty major densification to the network architecture, but it hasn't been by deploying small cells or increasing the site numbers at all. But what we have done is increased massively the frequency reuse. And we did a lot of this before massive MIMO was available and before multi-user MIMO was available. We invested in some what we call lens technology. You may have seen it in kind of like stadium type deployments where there's massive volumes of customers. The lens technology can allow pretty dense frequency reuse. So we've actually deployed that out into our commercial network onto hundreds of sites now to reuse our spectrum assets. That's been an important part of the evolution. Another part was the introduction of a new device. I think it was back in 2018 when we did bring through the category 16 device that allowed us to deploy higher order modulation, 256 QAM and carrier aggregation. Actually, before 2018, those sort of features actually didn't exist on our network. One big reality for us, though, is that now we have about 200,000 square kilometres of coverage. About 2,400 sites have been deployed, just at the very tail of that over a 10-year period. We've got all those sites out there. And about 395, almost 400,000 customers on that network, with the capacity, just keeping on growing every month. So for us, it's all about increasing the spectral efficiency. Of course, the spectrum is a scarce resource. And for Sam and myself, the main job is about how to drive sustainable spectral efficiency growth and capacity growth into the network without blowing the budget. Now, Sam's going to talk about the next phase of our growth, which is going to kick off with millimetre wave 5G, but it will also move into refarming of our centimetre wave band 40 and band 42 spectrum assets over time to refarm those into 5G. But as you might imagine, one of the big headaches that we have is that now we have about 400,000 of those things that you can see on the slide bolted onto rooftops around the country. And the job of going out and of course, it's a professional installation. There's health and safety implications of trying to swap those devices. And trying to swap those out for 5G capable devices overnight is just not a realistic proposition. It will cost billions of dollars and take probably a decade to get that to actually to be done. So it's quite a challenge. We've got a pretty successful network, but it takes a fair bit of doing. Sam, you might like to jump to the next slide. We'll keep this moving, mindful of time. I think we will have some time for questions later on, though. A couple of other fun facts about the network. It was built in a like a star topology, which you can see there on the slide. To date, we actually have a flat layer 2 backhaul architecture, predominantly using microwave. We've got about 80% of our sites are connected still by microwave. So we've had to drive new microwave technologies into the field just to keep up with the capacity, quite often carrying about 5 gigabits per second over those microwave links. But over time, we're connecting more and more of our sites via fibre. At the moment, it's only about 20% of the sites, keeping in mind that they're quite remote. They're not in CBD type environments. But what we are doing is trying to close rings as well, because that architecture you can see on the screen, it doesn't really have a strong resilience architecture to it. If we have one of those sites at the lower down in the chain, we can actually get multiple site outages, which is not at all a good customer experience. So we're deploying some, for us, new technologies like IP-MPLS into the network and creating some ring topologies so that we have better resilience there as well. As I say, the next step for us is to push new technology into the network. There is no 5G in the commercial network yet, but we have been doing a lot of testing, a lot of validation, and we should have 5G commercially activated in the network around April, May next year. And I think I might hand back to you, Sam, to just share some of our experiences with the new millimeter wave 5G technology and some of our plans for the future.
Sure. Thanks, Mark. So I think, obviously Mark's touched along the long history of the fixed wireless network in NBN and the scale there. Throughout that period, we've been pretty aware that capacity is a big challenge, and millimeter wave was something that we saw pretty early on with our partners as an opportunity to create both speed boost and to make use of the capacity there. So we actually started investigating this all the way back 2018 and before. If you sort of fast forward a bit, I'll take you through the timeline. 2019, really the Verizons of the world and various other markets were pretty much focused on short range, small cell type deployments. Still fixed wireless access was being considered, but very central urban areas. Particularly, we started to look at the link budgets and think about it. Our network deployment's relatively unique with that complete 100% externally installed, professionally installed CPU, which gives us a pretty unusual RF quality environment. And so we've got pretty solid link budget availability to us. And we think there's a good portion of the network where we could get line of sight and we'd be able to make use of the millimeter wave pretty effectively. In 2020, we did some trials with Ericsson and Qualcomm, and we demonstrated and set a couple of distance records, achieving 7.3 kilometers, I think, in 2020. 2021, US Cellular and I think Tim, one of the Italian operators, I can't remember, picked up the mantle and pushed it a little bit, and I think it's out at about 11 plus kilometers now. We've done some trials out at 10 kilometers and seen those very successful with peak speeds of north of a gigabit. In fact, pretty sustained speeds of north of a gigabit and peak speeds north of 2 gigabits, even out at 10 kilometers with our CPE design. And then 2022 for us is really the year of commercialization and getting ourselves ready. We've done a bit of work with 3GPP to make sure we had all the right device combinations, band combinations that we needed, and support for the features that we would want. And then, as Mark says, starting the build with a view to actually having commercial services next year. So that's, I guess, the history of our exploration of this. The way that we've been looking at it, we've got this 4G mid-band, 2.3, 3.4 gigahertz or band 4042, and that provides us a very solid coverage layer and capacity layer, which we've been using for the varying periods since 2012. What we've sort of quickly realized was pure millimeter wave or a standalone millimeter wave network wasn't likely to achieve our outcomes. An NSA deployment is available relatively quickly in terms of the standardization and the ability to implement as an overlay on top of our 4G network. As Mark said, we don't have a prospect of switching off 4G anytime soon because of the very large installed base. But if we pair that up, then we saw that we could get pretty extended ranges. Our current 4G network tops out at about 14 kilometer cell radius. And some of those expansions I was talking about earlier are going to push that cell range out even sort of towards the 30 kilometer or beyond range, where the topography allows and where it makes sense. So we'll get some coverage, but we won't ever try and, I don't think, match the millimeter wave coverage to the underlying 4G centimeter wave. But we could see potentially a little bit of an expansion if and when we refarm some of that existing 2.3 and 3.4 gigahertz spectrum. We might get a little bit further. One of the things hopefully you notice is those ellipses there get a little bit shallower. The further you stretch the range, there's a bit of a trade-off. You don't necessarily want to maximize the range because all of our bands are TDD bands. So the more you extend the range, the bigger the guard periods, actually the less system capacity you get. So that spectral efficiency point that Mark said, there's definitely a balancing point where we want to make sure that we get enough people onto millimeter wave to offload the mid-band to be able to lift the speeds for everybody and get as close to equivalence across the entire user base, rather than sort of really just chasing one user close to the tower being able to hit 5 gigabits, which is possible, but doesn't really fit with our vision and mission. So this is the test site that we have out in Western Victoria. We've been using this for the last two or so years. It's got gone through varying vendors' live network equipment on the top and various Qualcomm devices and test devices along the way. You can see some of the test locations there. This area is particularly flat and great for long range testing. So that's how we've been working pretty closely with our partners. And it hasn't been something that came automatically. Definitely required a little bit of effort across all parties to get this to work. But we think there's great potential for this to be able to provide a step change in terms of the available capacity in downlink and also in uplink. And that's where the focus will be from now. I think that's probably enough, Mark, unless there's anything else you want to add. Probably enough for us to go to questions. Okay.
All right. Thank you, Sam, and thank you, Mark. Great presentation and many interesting insights. There are some questions here. But maybe I can start with one question related to data usage. I think you mentioned a bit on your network overall traffic growth. You talk a bit about the 300 gigabytes per month for fixed wireless users. So could you give us some comments on how you see, let's say, consumption of home broadband across technologies? Is there a difference? And then a bit on when you look at the future, how do you see traffic growth? Is that driven more like, are you going to get more customers, or is that usage on the home? Is there a change on, let's say, downlink uplink ratio? I think I'm sure a lot of people planning, we would like to hear some of your insights.
Sure, maybe I'll take that one, Mark, if that's all right.
Yeah, go ahead.
So across the technologies, there's a little bit of a difference. Satellite is the outlier. That one currently has varying types of product constructs that involve gigabyte limits per month. But across the other technologies, there's really not very much in it in terms of the total consumption. Fiber users typically have the highest consumption, but it's maybe a few percent different between fiber and FTTN or HFC or DOCSIS on the fixed technologies. Fixed wireless is a little bit behind. It doesn't stay 100%, but the average usage, as Mark says, is north of 300 gigabytes a month on fixed wireless, and on fixed line it oscillates, with seasonal demand changes and variations, but it oscillates around the 400 gigabyte a month mark. So the averages come out pretty close, and we've got many users on the network that use north of a terabyte of data on fixed wireless. So absolutely, once you offer somebody a fixed broadband service and kind of bill it and sell it as a fixed broadband service, it gets used and consumed in exactly the same way as any other fiber-based technology or other fixed broadband-based technology. So we absolutely see that, and that's really been the driver for our consumption and some of these very complicated engineering solutions to have huge frequency reuse around the sites to be able to serve that, and drives us to want to add millimeter wave and do things like that.
I think maybe just to add to that, one other interesting statistic is that when we have our peak demand events, usually it's a fortnight patch being deployed or an upgrade from Epic Games, our good friends over there. What we measure is the mean busy hour throughput at that time, the peak event. What's the number of megabits per user in the different technologies? So that's where there's loads and loads of users that are just loading up the bottleneck wherever that happens to be. For us, it's the access link between the base station and the end user. Fixed wireless is running about 2.3 megabits per second during those events at the moment. That's right across our network, across 400,000 odd customers. The fixed line technologies are not very much higher. They're at 2.4, 2.5 megabits during those same events. So our conclusion here is that there's a little bit of contention in our network where we're supply constrained a little bit, but not majorly. We're pretty much meeting the demand. We are undertaking some massive upgrades right now. I think they were mentioned in one of the earlier slides, and what we expect is for that peak demand event to approach the fixed line. So there is no there's no supply constraint there actually.
Excellent, very good. Now there was one question related to a bit on the number of fixed wireless access users and that percentage. I think it is 400,000 compared to the overall base. Maybe could you elaborate a bit on, let's say, the technology mix and how is the decision process? Any learnings that maybe, I think there are many operators also using multiple technologies. Anything on that decision process that you can share some learning on how that is done?
Yeah, I think so. We've learned some lessons along the way, some do's and don'ts. We've probably done some don'ts there as well. It's about 5% of the total the total Australian premises that are in fixed wireless right now, that are serviced by fixed wireless access. Out of about a million premises that are on fixed wireless and satellite. So one thing that we are working over time is to bring as many of those premises into the fixed wireless footprint as we can. This is just to provide a sustainable long-term service for those users. Some of those are going to low Earth orbit satellites and other 5G mobile connections, that kind of stuff. But what we're headed to is to go to about 7%, something like 7 or 8%. Of Australian premises to go over to fixed wireless. What we have found though is that you can tip it, you can push fixed wireless into areas that are just too dense, and frequency reuse and the practical limitations of antennas and frequency reuse become a limitation. You can only serve so many customers within a certain arc for a given amount of spectrum. What we've found is that we can service something in the order of 10 users per 20 megahertz of spectrum that we have. We have to keep reusing that, but we can't. What we've found is that with centimeter wave, the beam width of the antenna that we can get down to, it's about 15 degrees, and that's similar to the multi-user MIMO reuse azimuth for a massive MIMO solution. So you can't, that kind of defines the limitation of spectrum. Now, having said that, we do have a gigahertz of millimeter wave 28 gigahertz spectrum pretty much right across our footprint. The problem, the challenge with a millimetre wave is that you do need clear line of sight to be able to use it with our site spacing. We don't have and we don't intend to do high density small cells in order to utilise that spectrum. So we can offload a certain number of our customers in places where there's flat terrain and little foliage. We can offload a lot, and that means that we can get more customers overall covered because fewer of them need to be on centimetre wave. But in some of the areas of Australia, we have an expectation of practically zero millimetre wave connections, and that means that the number of users and the density of premises that we can serve is really limited by the physics of the antenna and the reuse azimuth and the number of megahertz that we can obtain. There's some places where we're badly spectrum constrained, and it's a real challenge. Those are places that quite often fixed wireless just is not the right solution, and ultimately fixed line is where we need to get to. It becomes a business case discussion about how we get ourselves over to fixed line in that case.
All right. You touch a little bit on the, let's say, your device journey, that you start with a Cat 4, then I think you added a Cat 16. Now you have a Cat 20. And can you mention a little bit on, let's say, it looks like some of these users have been many years with the same device, maybe more than 5, which is,
there is.
There's
some devices out there that have been in operation for 10 years.
10 years. Okay.
Actually been in operation for 10 years. And some of those early versions of the device may end up being in the network for as long as 15 years. And it's a drag on the network for spectral efficiency. It's a real challenge. But at the moment, we have something like 185,000 of those older style Cat 4 devices. If you want to swap those, you've got to do thousands per month. There's a difficulty with getting out there and swapping those devices. Firstly, we need a professional, trained technician to climb onto the roof and swap the device. But it's not. You can't just assume that you can go onto somebody's property and swap their device, especially if you have to get inside their home to swap the indoor unit that's inside that feeds the power and has the actual Ethernet interfaces. So it's quite a sort of logistic challenge to be able to renew the fleet. That is one of the big challenges for us, and one of the big capex spend items for us as well to maintain that network is to renew the fleet of devices.
But you also renew your wireline fleet as well. Is it a similar challenge or similar type of cadence?
Well, I think once we've got an FTTP GPON modem out there, that's going to be pretty good for quite some time. We may refresh it, but it's not quite the same thing as these devices where you've got to have a technician come and climb onto the roof
and they are much more spread geographically also. So let's say the kilometers of driving per home, it's a bit different.
Yeah, that's true. The reach of the network's not so massive right now, though. Like we're fairly the actual coverage areas are pretty clustered. The up until just recently, the limitation for the range of connections from a base station was up to 14 kilometres, and we had a time domain limitation out to 14 Ks. We are extending that now, which can push out the distance that technicians might have to drive. But that's just it's another consideration, that's for sure. Yeah.
Okay. Maybe a final question here. So you have here really the whole 3GPP fixed wireless ecosystem. So if you would have any asks or recommendations for the ecosystem, or how can we support and drive more fixed wireless? Any things that you'd like us to help or work with?
Sam, do you want to take that?
Yeah, I mean, I think the key thing for us is obviously about getting the scale and the volume. Although we have a pretty big fixed wireless network as far as it goes, it's still tops out at 750,000 premises. So I guess the scale locally probably is not as big as the handset shipment devices or something like that. So absolutely, I think similar deployments around the world can work in many places, and I think we're very keen to see that take place, and happy to come and share our experience and learnings with people if there's a need to help explain in any more detail with other operators or whatever. We're probably quite happy to do that and have direct conversations, and then continued exploration of ways to reduce the costs. There were some interesting questions there about how to avoid site visits to upgrade devices. This is chipset limitations. So, if the ecosystem can develop ways that ease those challenges longer term, then for our next version, but of WNT, that's probably out in the back end of the decade. But anything that will help with those particular challenges, I think, are the key, and getting scale behind all of these capabilities, I think, is particularly important. And that long range millimeter wave one is definitely an interesting one for other networks, I suspect, to explore and have a look at.
Excellent. So thank you. I think it was very insightful and very good. I think really the scale of the ecosystem is very important, and we look forward to continue supporting you. And of course, I hope this case is a very good inspiration for other service providers, regulators on how to close the digital divide. So a big hand for Sam and Mark. Thank you very much. Now back to Julian and Joe.
Thanks a lot, John. Thanks, Sam and Mark. That was really, really insightful. Thanks for sharing so many details about your experience in Australia. I think it's inspiring. So now, Joe, I hope everything's fine on your side now. And please, can you maybe explain a little bit what we are going to do in the coming weeks with respect to this fixed wireless access device database, and maybe show a quick demonstration?
Yes, of course. So for some reason this is not allowing me to share my screen for some reason. Because I'm using a different browser. Let me see if I can organize this. We'll come back at the end, because if for some reason it's not working again.
Okay, so we'll move straight to the presentations from our sponsors. So we will have two presentations. First one will be from Jeff Liu, Regional Sales Director at Fibocom. And the next one will be from Kevin Wang, General Managers of Overseas Markets and Sales from Todd Scanway. Jeff, can you start? Thanks a lot.
Yes. Hi, everyone. Thank you for being here to attend this event. My name is Jeff Liu from Fibocom Wireless. It's my pleasure to introduce Fibocom and our products briefly, also the value we can offer in the FWA supply chain. Okay, so Fibocom was founded in 1999, and now we have 23 years experience in module making. Fibocom is the first module company we stock listed. We focus on module market and cooperate with multiple chipset vendors such as MediaTek, Qualcomm, and Unisoc. We have more than 2,000 employees worldwide, including more than 1,200 engineers. And our research experience is increasing yearly. Our headquarters is in Shenzhen, China, and we have branch office in major cities in Europe, Asia, and US to provide local support if needed. Okay, this is the overview of our Fibocom modules. As you can see here, we have complete product categories. We have a module to support Wi-Fi, GNSS, 2G, 3G, 4G to 5G, and from high speed to low power. Our module can be used for different products like laptops, automotive, parts, and also the FWA, which is the key topic for this event. Also, we can customize our modules based on our customers' needs, and we will collaborate with them to build the most competitive products. And in this slide, I would like to show you our success in the 5G FWA market till now. So you may know the carriers in different regions have different requirements for their products. So we cooperate with our customers to build a competitive products to win a business in their target areas, such as in North and South America, Middle East, West Europe, South Africa, and also Asia Pacific. We also have the shipping records for the 5G modules. And in 2022, we have participated more than 60 carriers official tenders and kick off more than 150 projects with our customers. And our target is to support the more than 10 million FWA opportunity in the coming 2 years. Okay. And in the coming slides, I will show you 5 core modules for the 5G FWA products. They will support the interface needed for the FWA products, such as USB or PCIe's. And this one is the FG360. It's a LGF form factor, and it's based on the MediaTek T750 chipset solution. T750 is the first 5G FWA SoC. It can support 4-core A55 CPUs and the original OpenWRT based Linux. And for different product requirements, we have offer different flash and the RAM configuration. For example, for the EU SKU, we have 1 GB plus 1 GB, and for the North America SKU, it will be 2 GB plus 32 GB. Okay, and also can support a different Wi-Fi configurations such as AX 18,000 or AX 33,000. And especially this module can support the interface such as the HDMI, so our customer don't need extra components for the Ethernet port. Also, the FG360 supports a new 5G new radio features like the low-band 4x4, MIMO, and the power class 1.5. With FG360 success, we use our development experience to improve our module design to provide our customer with competitive products and a new generation of the FG370. FG70 is based on the MediaTek TA30 solutions. Actually, the MediaTek TA30 is a new generation of a 5G FWA solution. It can support, with this solution in our module, we can support more flash and memory configuration and more advanced Wi-Fi configuration, like the Wi-Fi 7. The most important is the FG370 is pin-to-pin compatible with FG360, which means our customer can migrate to the new module with a minimal effort. Also, the FG370 can support up to NR4CA in downlink and also 2CA in uplink. Also, other new radio features such as Release 16, and also 8RX. And also, we have the module from Qualcomm Solutions. For Qualcomm Solutions, we have FG160 and FM160. The prior one is FGA form factor, and the later one is the M.2 form factor. Both are based on the Qualcomm SDX62 chipset, which is the latest commercial version of Qualcomm 5G solution. For 160 series, we can support up to 4CA in downlink and low-band 4x4, MIMO, power class 1.5, and the global 5G bands. And with Qualcomm 4nm process, this 160 series has lower power consumption And for another Qualcomm chipset, SDX65, we have module FG170. FG170 can support a sub-6 GHz and also a millimeter wave. So it can support up to 10 CA in downlink and 4 CA in uplink. Also, it's pin-to-pin compatible with our FG160 series. So our customers, which can help our customers to shorten their product development process and accelerate the launch of the products. And Fabcom, well, we collaborate with our customer to provide a product for different scenarios, like the industrial, enterprise, home connectivity, and the vehicle mobile. We can provide a module product, a whole product design, support, and also software customization with our expertise. And also we assist our customer to pass the interoperability test with some base stations, and also the certification for different carriers. And we have a rich experience on it. So per our experience, we provide the white paper to introduce more about the 5G FWA products. So you can download the file by scanning the QR code here. And we hope you can have some insight into the FWA products and our modules. So that is the end of my presentation, and thank you for listening. If you have any question, please don't hesitate to put in the chat room.
Thanks, Jeff. I will take some questions at the end. Now we will move to Kevin from Toast. The floor is yours.
Yes. Thank you, dear chairs and guests, ladies and gentlemen. I'm Kevin Wang from Toast Conway Intelligent Technology, or you can call it TKIT or call Ticket. It's my great pleasure to share with you our fixed wireless access devices. Today, I'm going to share with you who we are, what we do, and what makes us different. Here, for Toast, we are founded in 2002. We have over 20 years professional experience in MBB field. Who we are in terms of our global market, our business has covered over 80 countries. We reached over 30 million subscribers. We covering districts like Europe, Middle East, Asia, Latin America, and Africa. So for the company, 80% of the revenue is from international market. For the company itself, we have over 50% of our employees are from research and development. We are headquartered in Guangzhou, China. In Shenzhen, China, we also have our R&D center. We have sales regional head office in Germany, Europe, in Saudi Arabia, Middle East, and we also have global technical supporting team who are available to our customer. And we customize design and research and development and manufacture MBB products. For the capacity, our monthly production capacity is over 1 million units of MBB products. We also have the quantity approval. In terms of the customer MBB products, we produce, we design, we R&D 4G and 5G CPE, MiFi, dongle, and Wi-Fi 6 routers. In the industrial and enterprise level MBB and smart home and IoT devices, we have 4G and 5G industrial routers, fixed wireless phone, and GPON. Here, as you also may find from the video clip, some of our pictures of our products. And I'm glad to share with you for the past 3 years since 2020, our annual shipment has exceeded 3 million units. And by the end of Q3 2023, we have reached 3.5 million shipment. And it is optimistically estimated that by the end of 2022, 5 million units of MBB products can be shipped from TOZ Conway. And here is our success story. And we provide devices and service to Vodacom and Orange from Europe. And in other region, you can see we provide devices, for STC, Arido, and MTN, Airtel, and Dialog, and etc. And we are also one of the major supplier within the 3 mobile operators in China. We help them to win the market and to win the customer. We bridge millions of homes and enterprise much closer to the modern digital society. And here is our chips and module partner. We cooperate with Qualcomm and MediaTek or MTK so that we can produce the new products with the latest technology. We also cooperate with Unisoc and ZTE Senichip and Citron so that we can produce the cost-effective products for our customer. And as well, and you can see we have our ODM partners. We are on their list from their side. We are the hero behind. And here, finally, I'd like to share with you what makes TOZ different, why you should choose us. Number one is here we have full range of products. As you can see, we have products from Qualcomm and MediaTek, and also we have other cost-effective chipset solution, which means we can provide either the high-end cutting-edge products, or we can provide products at the cost-effective price with your requirement. So either you need high-end products or cost-effective products. Here for TOZ, we are here for you. And number two is our customer focus. We can tailor-made, we can customize for the requirement of our customer. And additionally, we are fast. We respond efficiently. That's number three. Number three is cost effective. In terms of price effective, we are proud to say that we are very, very efficient operation company. So we can control our operation and manufacturing cost. And for TOZ, we are also not running for high margin as our first priority. So we can provide very cost-effective solution from high-end to entry level. Additionally, for TOZ, we have very diligent employees which can help you at any time. So, okay, let's summarize. And thank you very much. We are looking forward to partnership with you. Please follow us in our Facebook, Twitter links for updates. And also, thank you very much. Okay.
Thanks a lot, Kevin. We will try now with Joe. Can you maybe show the demonstration now?
Yes, so maybe this will work a little bit better. For some reason, it's not allowing me to share my screen. So it says I don't have authorization. So for some reason, it was working in the test, but now it says I'm not. So I'm sorry for that. But maybe I give a little bit of background. So we've been looking at providing an online tool for our forum members to add their CPE module and device details into an online database that can be searched by anybody coming to the GSA website. So that is now in its final testing stages, and we will share that link once it's all been sorted and agreed. And you'll be able to then search for different fixed wireless access products from members of the forum. Any companies that are not yet members of the forum will be able to join and then add their data to that. So if you've seen the fixed wireless access devices catalog already, that is available through the GSA on the website. It'll be an expanded version of that with more details on all the products and the companies that are providing information. So look out for that information going forward. And again, I apologize for some reason where Chrome is not allowing me to share my screen.
Okay.
Back to you.
Yeah. Okay. So sometimes these things happen. So what can we do? Maybe Jeff and Kevin, maybe could you go back on with your cameras and maybe we could take some questions.
Yes.
During the last 5 minutes we have. So we have mentioned today the evolutions towards 5G and 5G fixed wireless access. There was a question about how to facilitate the evolution and the migration from 4G to 5G. So how do you take this kind of issues or parameters into consideration? And from your perspective, how fast do you see the transition to 5G fixed wireless access coming? How is it developing right now? And maybe, you know, when do you think 50% of your shipments or orders will be 5G fixed wireless access?
So I'll take the one.
Okay.
Yeah, from our opinion, we think the 5G FWA, it depends on the operators, because like in North America, like T-Mobile, they are the pure mobile operators, so they have a lot of requirement for the FWA. And for some other regions, like in Europe, maybe they have deployed the fibers, so I think they will deploy the FWA, but the speed will be slower than North America. That's what we see now, the trend, and also because the economic issue now, and we see the whole deployment speed will be slower than expected. Yeah.
And
so from my side, actually, this question is very frequently asked by our suppliers as well. So for the trend from 4G to 5G, it's to some extent it's similar to the 3G to 4G. But I think the fast evaluation from 4G to 5G, it will be faster. And I still remember, I can still remember, I read the Ericsson report. We still have 40 million, I think 40 million subscribers still in 4G. I think the evolution from 4G to 5G depends on the current layout of the operator, their deployment plan. I know now we have many countries that are pioneer in 5G, so it will be faster. But in other regions like Africa, Latin America, it will be much slower. So which means 4G still have a lot more time to take place in those areas. So that's from my view of point of view. Thank you.
Thanks, Kevin. Actually, because you mentioned this, I'm curious to know, both of you, what are the key questions you receive from your own customers? Because Jeff, your customers is maybe Kevin, so maybe you could ask him. But you know, it's always revealing what kind of key questions you are keeping, receiving from your customers, and what are they right now? Jeff, maybe you want to start?
Yeah, Jeff.
I think the currently the question from our customer, like Kevin's company, is the cost of the modules, and this would be the key, the major question from them, because I think for the CPE, the quantity for the CPE is large, and they expect to have a lower price, so the operator, the carriers can deploy more smoothly, because usually the carriers will, if their customers subscribe the service, they will just give the CPE. They won't take extra charge for the CPE. So for the CPE, they will be treated like as expense for the carriers. So they are looking for a lower price for the whole product, which means that as a key component in the CPE product, the FWA product, they are expecting a lower price for the modules.
And for the 5G CPE at this moment, according to my understanding, each operator driving, and in the open market you can find it. It's very expensive. So in the 5G advanced market, 4G, most of the operator I met from the advanced telecom country or region, 4G, they just you can buy it very easily from the open market, very cheap, and I think it nearly 30% or even 20% of the unit price for 5G CPE. So that's the reason 5G CPE is operator driven, and in the advanced area, 4G is really released for the open market. But for Africa and for other Latin America region, the operators still working on the 4G FWA. They buy it, according to my understanding. Yes. Thank you.
Okay, so unsurprisingly, price is the main thing, but in terms of features, I mean, we have just heard before with NBN, the move towards millimeter wave. So do you see this happening as well, developing a little bit faster than before, this request to have millimeter wave support? Or are you seeing, requests to support more antennas on the device? So any insight on the maybe technical trends you might see in terms of features right now? Maybe Kevin to start with first.
I think I just trying to understand your question. You said what the features,
yes,
for required from the customer, right?
Yes.
The place I live in, for example, in Saudi Arabia, in this area, so the telecom, they need very high configuration. Although for example, for the 5G CPE, they said we need 500 megabyte or even 800 megabyte. But for some operators, when they released to their subscribers through bundles, they place a speed limit to 200 megabyte. So I said, what you are doing? You are buying for very high spec CPE, but you just you buy a big pipe, but you only give them a little proportion of the water, make only little use of the pipe. So that's the situation at this moment for the configuration. I think the advanced area, the mature 5G market, they need very high configuration. And for the other region, relatively, they need a cost-effective entry level. That's what my insight. for this issue. Okay, thank you.
Thank you. Jeff, is there anything you want to add? You just presented your new modules with lots of advanced features. What is the driver behind?
I think for the feature side, it will be the low-band 4x4, the MIMO, 4x4 MIMO, which is required and by some operators, and also the Power Class 1.5 is also a new feature we've seen recently. So, which is to improve the penetration rate inside. Yeah.
Okay, so I think we are already 5 minutes behind schedule, so maybe we stop the Q&A now. And thanks again for your contributions and presentation today, and the sponsorship as well, of course. Thank you very much for your support. I will now maybe hand over to John for the closing remarks. John?
Thank you, Julian. So just to summarize a bit, I think really, as you can see and heard from various speakers, the need for reliable and affordable broadband has never been greater. Closing the digital divide, it's very important, as the pace of digitalization and the need of broadband to work, study, socialize continues to be very important. Multiple technologies are needed to close that digital divide, and fixed wireless is a key ingredient in that, complementing fiber. You saw some interesting examples of fixed wireless, like with NBN, with over a decade of LTE-based fixed wireless, and now they are working on a next evolution on that path. And I think we also discussed a lot about how we see the increased scale and more deployments of fixed wireless across countries, and the importance of the scale of the 3GPP ecosystem really enable a vibrant market for operators to monetize 5G investments. So I think that was the fourth plenary. Very good questions and dialogue. We from the GSA Fixed Wireless Access Forum continue to work on our objectives, gathering the key players of the industry, supporting this use case, and providing additional information. And we will be happy to continue that dialogue. And you can always reach out to the GSA to get in touch with us and see how you can be part of this group. So with that, I close here. I pass back to Richard.
Lovely. Thank you very much. And I'd just like to close today's plenary once again, thanking you and all our speakers for joining us today. After the event, you will receive a link to the webinar recording. All the presentations will shortly be emailed to you in that email, and also be available for download from gsacom.com. Our next event, as you'll see, is in 3 weeks, where we'll do our annual look back at the year's big trends and milestones, and look forward to what we can start to possibly expect to see in 2023. For the latest updates on all GSA research activities and upcoming events, please do follow GSA on social channels. You'll find the Global Mobile Supply Association on Twitter, LinkedIn, WeChat, and Weibo. And if you visit gsacom.com, you're able to subscribe to our weekly Research Digest email and new report notifications. So finally, on behalf of the GSA team, all that remains for me to say is thank you again for joining us, and we hope to see you again at the next GSA event. Many thanks.
Thank you.
Thanks, Richard.